Good morning, students. You might recall that in our last lesson, we looked at how we could find the point of intersection of two straight lines. This is called solving a linear system. It's known as a 2 by 2 system since there are two equations and each of those equations has two unknowns. That would be x and y. So we used the graphical method in our last lesson. We actually plotted x and y intercepts for the lines, physically drew them on graph paper to see where they would cross. In today's lesson, we'll focus on a method that uses algebra instead, and it's called elimination. So here are our two straight line equations. So when you use elimination, you want to look at the coefficients in front of x and y. So here we have a 7 and a 2. Here we have a 6 and a 5. So to begin this method, you choose one of those variables and you multiply the equations by numbers such that these coefficients will become equal and with opposite signs. For example, if I want to eliminate x, I might try to make one of these numbers 14, perhaps this one, and the other negative 14. That would mean multiplying, so this is a multiplication sign, multiplying the first equation by 2 and multiplying the second equation by negative 7. So let's see what that will do here. So I'm going to multiply the whole first equation by 2. And multiply the whole second equation by negative 7. And that's what the equations become. And now we take a quick look and we see, yes, indeed, in front of x we have the same number, but with opposite signs. One is positive, the other is negative. This means that we can now add the equations together. So we're going to take the two equations and add them. Now, when you add 14x and negative 14x, of course, you get 0. So now let's add here. We're going to have negative 23y. And let's add here. We get negative 23. And at this point, you can see that we can solve this for y, since this equation involves only y. So we divide both sides now by negative 23. So y is negative 23 divided by negative 23, and therefore y is 1. And that's how you use elimination to solve for y. Okay, I'm going to do the same thing now. So we're going to go back to the beginning here. And instead, we're going to use elimination to solve for x. And that means coming up with the proper multipliers here for y. So that one is a 6 and that one is a 5. Both of these numbers go into 30. So my goal is going to be make this 30y and this negative 30y. So to get this to be 30y, I'm actually going to multiply that top equation by 5. To get this to be negative 30y, I will multiply that top equation by 6. Okay, so I'm going to execute this plan now. So multiplying the top equation by 5 will give me 35x plus 30y is 100. Now we multiply the lower equation by 6. Negative 6, because we want this to be negative 30y. So this is negative 12x minus 30y is negative 54. So before continuing, check quickly. Yes, indeed, I do have the same number here now in front of y and with opposite signs. This means that I'm at the point where I can add the two equations together. When I add the equations together, of course, I will get 0y. But first, here I will have 23x, and here I will have 46. So this equation now only contains x. X is isolated by dividing 46 by 23, and we will get 2. And at that point, we're done because we have first eliminated x and solved for y. Then we have eliminated y and solved for x. And when you write your answer, you write it as an ordered pair. So you make sure you write the value of x first and then the value of y. Okay, in this example, I wanted to do elimination twice, right? So we had two sets of multipliers, one that gave us this scenario, the other that gave us this scenario. When I do the next example, I'll only use elimination once. There will be a simpler way to find the second variable once we have determined the value of the first variable. So why don't we try that second example now? Okay, so here's my equation. Now, I have a choice to make. I can either choose to eliminate x and solve for y first, or I can choose to eliminate y and solve for x first. And it doesn't matter what I choose. Okay, so you're gonna have some choices to make off the bat. So if I take a look at this, I think what I'm gonna do is eliminate x. So what do I want? I want for one of these to be, oh, look, in this case, I have 4x here. I can make this negative 4x simply by multiplying that second equation by negative 2. All right, so the first equation can stay the same. The second equation can be multiplied by negative 2. So that will be negative 4x plus 6y is equal to 44. I can check to see that, yes, I do have here same coefficient and with opposite signs. One is positive, the other is negative. So this means that I can now add the equations together. And x will be eliminated when I do this. I have 0x. How many y's will we have? Negative 5y plus 6y is 1y. Add these two numbers together and you will have 10. So y is 10 divided by 1, or y is equal to 10. Okay, so this is what I did in order to eliminate x and solve for y. I want to point out you could have done something different. For example, maybe you wanted to make the top coefficient negative 8 and the bottom coefficient positive 8. So that would work as well. So you could multiply the top equation by negative 2 and the bottom equation by positive 4. And that would give you a negative 8x here, a positive 8x here, and then you could have added the equations. So that works as well. If you preferred, you could have eliminated y. You could have made this top one positive 15y and this lower one negative 15y, for example. Okay, so there's a lot of choices to make at the beginning, and really, one will not be much easier than another. Okay, but what I chose to do was just multiply the lower equation by negative 2. That gave me this desired situation here, and I now have my y value. So instead of using elimination again in order to solve for x, I can just substitute this value now into one of the first equations. For example, I can substitute it into equation 1. So equation 1 says 4x minus 5y. This means minus 5 times y, and y is 10. So I have this. 4x minus 5 times 10 is negative 34. So I'm substituting into this equation right here. So what does that mean? That means 4x minus 50 is negative 34. 4x then is negative 34 plus 50. Which is 16. And that will give you x equals 4. X is 16 divided by 4. X is 4. And at that point, I'm done. So I used elimination once, and that got me a y value equal to 10. Y value is 10. Then I simply substituted into the top equation to get x is 4. And another note, I could have substituted y equals 10 into this second equation instead, and I would still have arrived at this value, x is 4. Remember, this is the place where the straight lines would cross on the graph. Okay, let's do one more example together, and then it'll be time for you to try some, okay? So one more example. This one has P's and Q's instead of X and Y's. So it starts looking like this. Okay, so 5P plus 4Q minus 14 is 0. 17P is 31 plus 3Q. Now, if we want to use elimination, we have to have a form more like this. Okay, so first variables, second variables, equal signs, constants. So we're going to change the look here. So in the first equation, what does that mean? This constant needs to be on the other side. So 5P plus 4Q is, now we add 14 to both sides. So this will be positive 14. So this one term moved. What about the second equation? Well, 17P is already where it needs to be on the left side. We need this term to come to the left side. So we must subtract 3Q. That's the only term that's moving. The constant is already correctly on the right side. So this should say 17P minus 3Q is 31. Okay, just like that. And now we're ready to begin. So we've got the P's, the Q's, the equal signs, and the constants. So one term moved in the first equation, one term moved in the second equation. And when I say moved, I mean crossed the equal sign. Okay, now I could choose to eliminate P or Q. To me, right here, this is a pretty good situation. I think I'm gonna try to get 12Q here and negative 12Q here. How can I get 12Q here? Multiplication by 3. How can I get negative 12Q here? Multiplication by 4. You see, these two numbers are positive because the signs are already opposite. All right, let's execute the plan. So we triple the first equation. 15P plus 12Q is 42. The second equation will be multiplied by 4. So what's that going to be? 68. P minus 12. Q is 120. and 24. Okay, now before proceeding, check, did we do this correctly? Looks like it. Look, 12, 12, 1 positive, 1 negative. Add the equations together. Okay, when we do that, how many p's will we have? Well, 15 plus 68 is 83. Of course, we're going to have 0 q's. This number, when we add 42 and 124, we get 166. So what is p? P is 166 divided by 83. P is 2. Okay, now how will we determine q? Well, we could do this whole kind of thing again. Repeat the whole thing, but this time start by making the same numbers in front of p, but with opposite signs. Or the other way, the easier way, is to just take this p value and substitute it into one of the first equations. Okay, or you could even substitute it into one of these rearranged equations. All right, so you can pick any one of those that you like. I'm going to choose this one right here. So I'm going to substitute p equals 2 into that equation. So right here, this will be 5 times 2. 5 times 2 plus 4q is 14. So 10 plus 4q is 14. 4q will then be 14 minus 10, which is 4. And q is 4 divided by 4, or 1. And then we're done. We know p and we know q. When you go to write the ordered pair, you know how it's always x before y. When the variables are different like this, we use alphabetical order. So p before q. So 2 and 1. So that's according to the alphabet. Okay, we're all set. So I hope that you remember doing questions of this type back in high school sometime. And please take the time. I'm going to assign 4 questions for you to try from your textbook. You can check Blackboard for that reference, and please take the time to practice these. Okay, thanks a lot. Have a good day.